Welcome back, folks. We are back with another screencast on Phaser for JavaScript. Today is Monday, April 24th, 2017, and we're going to be taking a look at some more in-depth functionality of the Phaser game programming framework. Today we are going to be talking about adding in additional sprites, handling collision detection, and handling user input. Very vital things for game programming. All right, folks, so let's get right into it. We have here our play.js. Play.js is where we are handling the bulk of the game loop and the creation mechanisms for our game. And we have a player object. I also have an enemy object here. We are going to be using this enemy object later when we add another character onto the screen. And this player object has now a couple of different properties. The properties are the X destination and the Y destination. Now, why do we need X and Y destinations? Well, as I had said in the last screencast, we were going to be handling user interaction via mouse input, or if you're on a tablet, touchscreen input. So what we want to do is we want to set up waypoints. We want to click on the screen and tell our character exactly where it is we want him to go. And we are going to do this by within our update phase. If you remember, the update phase is where we handle the majority of our game loop and basically all of the functionality that happens every time the game cycles through. So obviously, if we're waiting for mouse input, we want that to happen within the update function, because every time the game updates, the screen refreshes, we want to be listening for a new mouse input. So what we are going to do is every time the game input active pointer is down, we are going to listen for that particular event, and we're going to take the X coordinates and Y coordinates from that game input, and we're going to set it to the X destination and Y destination of our player. So what this will do is this will give him a waypoint, it'll give him a destination where we want him to go. And if we, let's see how that looks. Okay, so there you go. We clicked on a spot on the screen, and it says that that's going to be an X coordinate of 327 and a Y coordinate of 75, and that would be his destination. So let's take that out just for the sake of example. Now, what do we want to actually do here? Well, we want to move the character. So we will create a function here called move player. So let's take a look at what we've done here for this move player function. And looks like a big function here, but it's really not overly complicated. So move player is going to, let me just comment out this comma over here. Move player, what it's going to do is at the beginning of all our functions, we set self to equal this so that we can make reference to the player object throughout the function, regardless of scope. And we are then going to take the X and Y coordinates of our player object, and we are going to take the player.x, and we're going to check to see if the player.x is equal to the X destination. If the two values are equal, and I'm taking a floor and dividing this by 10 because what we want to do is we don't want it to be exactly equal, because we're dealing in these decimals where if we try to get the numbers to be too exact, they never quite match up. That's why I'm taking a floor of it and dividing by 10. And I'll show you why in a little bit. But for now, let's just actually, you know what, just for simplicity's sake, we can even just say, if player.x equals player's x destination, then the velocity is equal to 0. If the player's x coordinate is less than the x destination, then the velocity is equal to 80. And if you remember from the last examples that we looked at, the velocity was something that we got inherited from adding physics into our program. And we have the ability to adjust that velocity in both the x and y direction, so we can control the speed by which our player is moving. So if you think about this, what you'll see is if your player's x coordinate is less than that of the destination, then he's going to have a steady velocity of 80. If he reaches that destination, then it's going to be reset to 0. So that'll stop him dead in his tracks. Same thing for if the x coordinate is greater than the x destination, we send him in a negative velocity, which is going to take him to that coordinate that we're directing him to. And again, when he gets to that final destination, he's going to stop. Basically do the same thing down here for the y coordinates. Take the player.y is equal to the y destination. We zero out the velocity. And if it's less than the y destination, we set the velocity in the y direction to 80. And if it's greater than, we set the velocity of the y in the y direction to negative 80. And this will again get him moving in the correct directions. I commented out a couple of things here. I just didn't want to distract from what I was talking about here. But basically, setting the player.scale, well, let's take a look. Let's get him moving first, and then I'll show you why we want to have that in there. Let's refresh our screen here. So, excuse me. Now we click on a... Okay. So, well, most important thing we need to do here, so we've created this move player function. We actually have to call the move player function. So within our update phase, what we're going to do is we're going to call this move player on every iteration of the update function. Let's refresh. And it's not working. Hold on. What did I miss here? Okay. We need to make sure that we enable physics for the player. Save that. Refresh our screen. Now he's moving. All right, now he's moving. Okay. So what you see here is our player is standing in a location on the screen. We click. That becomes his X and Y destinations. His velocities get set in the appropriate directions. And as he moves towards those particular directions, as he moves towards those particular coordinates, he will then, his velocity will be reduced to 0 as soon as his X coordinate matches the X coordinate of the input, or his Y coordinate matches the Y coordinate of the input, until eventually he stops where we want him to stop. And we can kind of shift his direction as we want in any way that we want. Now, one thing that you'll notice is, regardless of whether he's moving in a forward or backwards direction, he's always facing the same direction. So that's why we had this here. What this will do is it will scale the player in the X direction to 1 or negative 1. And the reason for this is so that when we move him in the, let's refresh the screen here, move him in the negative, when he's moving in the negative X direction, his the image is scaled to 1, which basically gives a mirror image of the character. This way we don't actually need to store a separate bitmap for his X and his Y direction. we just basically flip it on its x-axis. So there it flips it x equal to -1 and x equal to 1, depending on the direction that he's moving. This gives us a nice little view of the character in each respective direction. So now that we have a character that's able to move around on the screen, let's say we add another character in. And we are going to do that by comment out this part over here. Okay, so now what we're going to do is, if you remember earlier I said that we also had an enemy object that we had added into our play state. And that enemy object has a location. We add a sprite to the screen with a location of 100 and 100. That'll put them somewhere around here on the screen. Again, we're pulling them from the characters sprite sheet. The character sprite sheet was this sprite sheet that we were looking at in the earlier screencast. And then we set his frame. His frame is equal to 544. Now, the player frame was set to 0, which basically got the player in this spot right here. And if you remember from our earlier screencast, we were able to get different images of our character by looking at the index of the character within this sprite sheet. So this would be 0, 1, 2, 3, 4, 5, etc. until you get all the way down here, which is the 544th frame in that sprite sheet. And then we are going to, excuse me, we are going to add the enemy to the screen. We are going to enable physics for that enemy because we're going to want to have collision detection. We're going to set the same anchor on that enemy to 0.5 and to 1. We are going to set the scale of that enemy to -1. That's going to flip him on his x-axis like we did for our main character there. And we are going to set that enemy's body to immovable. And again, that's going to be for later on when we're working on collision detection. So let's take a look here. And there he is. We've got our little gray up in the upper left-hand corner over there. And we can go over and we can chill out with him, whatever we want to do. He's not really, much of a threat to us right now. We just kind of pass right through him, which is not what we want to do, but, at least he's there. So that's nice. Now, what we do want to do is we want to enable some collision detection with this fellow. So what we have to do is, first of all, we're going to create another function here. And this function is going to be called stopPlayer. And what stopPlayer is going to do is it's basically going to reset the X destination to whatever the player's current X location is, the Y destination to whatever the player's current Y location is, and reset the velocity in both the X and Y directions to 0. Then we are going to use the physics engine that comes with Phaser that we included to check for a collision. And we're going to check for a collision between player and between enemy. And anytime that those two collide, we are going to make a call out to the stopPlayer function, which is part of the play state. And that should prevent our player from moving the minute he hits our alien. So our destination is over here. And you see, we cannot move past this alien unless we go around him. That's pretty much what I wanted to cover for today. So we're looking at now a game that has the ability to load multiple sprites from a sprite sheet, has the ability to handle input, has the ability to handle collision detection, and is able to animate the sprites. So we'll be taking a look at some more functionality in our upcoming video. Hope this helps you out, and as always, always looking for feedback. So thank you very much.